Okay, November 2022, paper 1, variant 1. Question 1. The times for 10 swings of a pendulum are measured. We have 3 timings. What's the average time for one swing? Again, we can just calculate the average by adding them up and dividing by 3. So 10.12 plus 10.48 plus 10.24 divided by 3. This would give me, okay, 10.12 plus 10.48 plus 10.24 divided by 3. 10.28. But this is the average for 10 swings. We need to divide this by 10, okay, so that it would be 1.028 seconds. This is the timing, the average period of only one swing. Average period of only one swing. A car starts from rest. The table shows the readings from its speedometer every 10 seconds. Which row describes the car motion for the first 30 seconds and for the last 30 seconds? The speed of the car in the first 30 seconds, it was 0, 4, 8, 12. So the speed was basically increasing. For the last 30 seconds, non-zero acceleration, non-zero zero, it's not zero acceleration, okay? Is it zero acceleration or is it non-zero acceleration? That's the question. It is accelerating, okay? It is accelerating. So this has to be a non-zero, okay? Accelerating, acceleration. So it's either A or D. For the last 30 seconds, 12, 12, 12. This means that it is moving at a constant speed. It's definitely moving at a constant speed. Okay, a stone is placed on the balance. Which row gives the mass and the weight? The mass is 120 grams. Okay, so weight equals mg. Most of you will just multiply 120 times 9.8, which is wrong. You have to divide the mass by 1000. Why? Because the mass has to be in kilograms. The mass must be in kilograms. So the mass is 120 grams, which is okay. The weight would definitely be 1.2 newtons. Which expression is used to calculate the density of the metal? It has a mass m, so density equals mass over volume. The mass is m and the volume would be P times Q times R. B. Question 5, a force F acts on an object at a distance of x from the pivot. Which two changes both? They both increase the moment. How can I increase the moment? I need to increase the force and I need to increase the distance. So increase F and increase x. Which object could be moving to the right at a constant speed? Could be moving to the right. Again, constant speed. What do I mean by a constant speed? It means that the forces are balanced, that the left hand or the force to the left is equal to the force to the right. The only case in this question is A. The forces are balanced. B is moving, okay, is accelerating to the right. C is accelerating to the left. D is accelerating to the right. Okay, the only case in which the forces are balanced, okay, the resultant force, okay, the resultant force is equal to 0. Left hand side equals right hand side. The force to the left is equal to the force to the right. The diagram shows a uniform rod with its midpoint on a pivot. Two weights X and Y are hung from the rod. The rod is in equilibrium. Which statement is correct? Again, whenever I say equilibrium, what do I mean by equilibrium? The forces at X have different values. No, the resultant turning effect. There is a resultant turning effect. No. The resultant force on the rod is 0. Ah, yes. The rod does not have a center of mass. Definitely, the rod has a center of mass. The resultant force on the rod is 0. This is one of the requirements for the rod to be in equilibrium. Brakes are used to slow down a moving car. Into which form of energy is most of the kinetic energy converted as the car slows down? As the car slows down, most of the kinetic energy is converted into definitely thermal energy. Okay. What is a disadvantage of nuclear fission as a source of energy? Nuclear power stations are expensive to build. Okay, they are unreliable. They can only provide small quantities of energy. They release large quantities of carbon dioxide. They do not release carbon dioxide. Okay, they do not release carbon dioxide. They provide actually huge quantities of energy. They are reliable and definitely they are expensive. That is the problem. One of the disadvantages. The statements describe what happens when a power of a machine is increased. Again, I need to increase the power of the machine. I need to increase the power of the machine. The work decreases. No, the work actually needs to increase. Okay, the work in a given time increases. The time taken decreases. Yes, when the time decreases, the power actually increases. The time increases. No. So 2 and 3 are correct. Okay. Power equals energy or work done over time. So you need to increase the work done and you need to decrease the time. Which quantities, in addition to the acceleration of free fall, affect the pressure at the bottom of a pond of water? Okay. The pressure below the water increases using the density of the liquid and the height or the depth below the surface of the liquid. The density of the water only, no, the depth, okay, density and area, no, okay, the density and the depth only, both of them. Density and the depth, both of them. Um, a fixed mass of gas is trapped inside the container. We have a fixed amount of gas. So this is the fixed, okay. The temperature of the gas is increased, but the volume is kept constant. We have temperature is increased. Whenever the temperature increased, we need to see what will happen to the pressure. Again, when you increase the temperature, the average kinetic energy definitely increases. And therefore, the pressure will also increase because they will hit the walls faster and harder and more frequently. Which row correctly describes the arrangement and the motion of particles in a solid? They are tightly packed and they vibrate, okay, about one position. They vibrate in fixed place. What's the temperature difference between, okay, the fixed points in a temperature scale? Again, the thermometer has been removed. The thermometer has been removed. So this this question is actually cancelled. But the answer is B. This question is cancelled. It has been removed from our syllabus. In the diagram, each box represents a state of matter. We need to find the different changes of state, P, Q, R, and S, from liquid to solid. Okay, from liquid to solid. This is freezing. Okay, Q, from gas to liquid. This is condensation. So it's quite apparent that the answer, okay, is either A or C. Again, from R to from solid to liquid, from solid to liquid is what? Is it boiling or is it melting? Definitely, it's melting, and from liquid to gas is boiling. So the answer is C. We have four thermometers with their bulbs painted different colors, and they are placed at equal distances from a radiant heater. Which thermometer shows the slowest, the slowest temperature rise? We know that the slowest temperature rise should have the black. No, not the black. It should be white. Dull white or shiny white. Definitely the shiny white will have the slowest temperature rise because it's, in this case, it's the worst. In this case, it would be the worst absorber of infrared radiation. Which method of transfer of energy is caused by the changes of density? The only one that has a change in density is the convection. The only one. Okay. We have two sets of wave fronts in a ripple tank. We have a barrier in the first case. In the second case, we have shallow water. The student makes two statements about the waves. When the waves reflect from the barrier, the direction changes, but the wavelength remains the same. In reflection, definitely the wavelength remains the same. So probably the statement would be correct. When the wave fronts refract as they enter the shallow water, the direction remains the same, but the wavelength changes. In refraction, okay, in refraction, does the direction remain the same? No, the direction does change. So this is the wrong answer. The only statement is one. The only correct statement is one. Which is the correct order of the colors in the spectrum of white light? We know them. Roy, hmm, Gibev, okay. Blue, no. Yellow, okay. Blue and green or yellow. What do you think? Okay, it should be blue, green, and yellow. Okay, blue, green, and yellow. Or is it the other way around? Okay, the only In this case, okay, we know that it is Roy-Gibev. What if I go from the other way around? Vibyor. Could be right. It could be right. So in this case, the only correct order would be blue, green, and yellow. You cannot say blue, yellow, and green. This is wrong. Yellow, no, it should be green then blue. So this is wrong. Green, blue, no, green, blue, and then indigo. Okay, so it cannot be green, blue, and yellow. So you need to eliminate the wrong answers in this question. An object is placed 30 centimeters in front of a plane mirror. Which statement describes the image of the object? The image is the same size. Yes, it is the same size. And 30 centimeters from the object? No, it's actually 60 centimeters from the object. Why is it 60 centimeters from the object? Is if this is the object, okay, and this is the image, okay, this is the image. The distance from the object to the mirror is 30 centimeters, and the distance from the image to the mirror is also 30 centimeters. So if you have 30 and 30 centimeters, the total distance from the object to the image would be 60 centimeters. This is a really interesting question. The distance from the object to the mirror is 30. The distance from the image to the mirror is 30 centimeters. But the distance between the object and the image, okay, is 60 centimeters. Again, read the question carefully. Read the answers here carefully. The image is the same size, yes, and 60 centimeters from the object. Okay. The first one, A, would have been right if he had said from the mirror. Okay. Question 21. Which two angles represent the angle of incidence and reflection? Okay, 2 and 3. The diagram shows the electromagnetic spectrum. The numbers indicate the approximate wavelength at the boundaries. For a device to be able to make use of the electromagnetic radiation, it needs an aerial. Okay, it needs what? An aerial. And approximately, okay, the same size as the wavelength of the radiation it is designed to work with. An aerial, okay, means that we will need to choose one of these uh, electromagnetic waves, okay? Which of these could use an aerial? A television satellite, mobile phone, receptor cells, the remote controller for a television. Let's discuss each of these answers. The mobile phone uses radiation from region P. We know that the regions are divided into Rami looks great. Rami looks great. R is the radio waves. So, do the mobile phones use radio waves? No, this is wrong. A television satellite uses radiation from region Q, radio, then microwaves. Satellite uses microwaves. This is correct. Receptor cells in an eye use radiation from region R, infrared. We do not have infrared vision. We have light vision. We can see the light. We can see the visible light, which is S. Okay, visible light. So this is wrong. The remote controller, we know that the remote controller uses infrared. So it's not from region U. Region U is the X-rays. So definitely B is the correct answer. Microwaves and X-rays are regions of the electromagnetic spectrum. Which statement about the microwaves and X-rays is correct? They have the same frequency. They have the same speed. Definitely, they do have the same speed. Okay. Microwaves actually have longer wavelength and they travel at the same speed. Okay. Question 24. An observer stands at the finish line of a 100-meter race. He wants to time the winner's run. He starts his stopwatch as soon as he sees the smoke from the starting gun instead of when he hears the bang. Why? What is the reason for doing this? Light travels much faster than sound, quite obviously. There's a risk he might respond to an echo. No. Humans react slower to sounds. Humans react more quickly. That's the only right answer. Right, light travels much faster than sound. Which description of a current in a metal is correct? It is the flow of definitely electrons. Definitely. The only thing that flows inside the metal is the electrons. The table shows the currents for different values. Okay, what is the order of the currents? Can I calculate each current? Yes, I definitely can calculate each current. I equals V over R. So V, which is the potential difference, 3.6 divided by 12, and then 1.2 divided by 12, and then 3.6 divided by 6. Let's calculate each of them. 3.6 divided by 12 is 0.3. 1.6 divided by 1.2 divided by 12 is 0.1. 3.6 divided by 6 is 0.6. Okay, the order from the smallest to the largest would be I2 and then I1 and I3. Okay, I2, I1, and I3. What does EMF stand for? EMF is the electromotive force, not electromagnetic. Okay, electromotive force. What are the directions of the electrostatic forces on rod P and rod Q? What does he mean by this question? In which way is rod P pulled or pushed? And in which way is rod Q pulled or pushed? This field, okay, P is positively charged and Q is positively charged and P is negatively charged. They are both oppositely charged, so they will attract each other. So in other words, P will be attracted downwards, it will be pulled downwards, and Q will be attracted upwards or pulled upwards. So the force on Q is downwards, and the force on, the force on P is downwards, and the force on Q would be upwards. So the answer would be B. Okay. Um, which circuit is used to measure the potential difference and the current? In other words, in which circuit do we have the voltmeter and the ammeter in their correct positions? The only correct position would be C. Sliding contact, we have a potential divider. Sliding contact. The slider is moved from P towards Q, from P all the way to Q. What happens to the reading on the voltmeter and to the brightness of the lamp? When it moves this way, when the slider contact moves from P to Q, what happens to the resistance? The resistance increases, and therefore the voltage increases and the brightness as well increases. They all increase. Why? Because it's moving this way, so the length is increasing, and we know as the length of a metal wire increases, the resistance increases. Okay, when the resistance increases, the voltage increases as well. When the resistance increases, the voltage increases, and therefore the brightness of the lamp has to also increase. So the voltmeter increases and the brightness of the lamp increases. Okay, this is quite easy. Okay. This question, you actually need to solve it a couple of more times. If you have not yet understood it, please solve it one or more times. Okay. The resistance of the variable resistor is increased. We increase the resistance of this resistor. What happens to the brightness of each bulb? What happens to the brightness of each bulb? As the resistance of the variable resistor increases, the voltage of the variable resistor increases, and therefore the voltage of P decreases. When the voltage of P decreases, the brightness of P will decrease. Why? Because the voltage has decreased. So P will become dimmer. Will Q be affected? No. Q will remain the same. Why will Q remain the same? Because they are in parallel. They have different branches. So Q will receive the same voltage no matter what happens to the variable resistor. No matter what happens to the variable resistor, Q will definitely have the same voltage of the cell. For example, if the cell was 12 volts, Q will have 12 volts. It will have a potential difference of 12 volts no matter what. But the potential difference of P will depend on the potential difference of the variable resistor. If the resistance of the variable resistor increases, then the voltage of the variable resistor will increase, and therefore the voltage of the P, or the potential difference of P, will decrease, and its brightness will also decrease. Question 32. Which diagram shows a circuit containing a battery, a fuse, and a buzzer? Actually, this question has been removed. Okay, this question is cancelled. Why is it cancelled? Because the buzzers and the bells have been removed. They have very slight difference in the drawing. This is the drawing of a bell. And this is a drawing of a buzzer. But they both have been removed from our syllabus. So you are not required to know how to draw a buzzer or a bell. Okay, the answer would have been D, yes, I know, but you are not required to know the difference in drawing the bell or the buzzer. Further on, you will not have any questions related to bells or buzzers. Why is a fuse used in an electric circuit? Why is a fuse used in an electric circuit? The fuse, what does it do? It increases the circuit resistance. It prevents short circuits. It reduces the power loss. It stops the cables from overheating. Yes, and this is what a fuse does to a circuit. Okay, question 34. The diagram represents a transformer. Which row shows materials suitable for making the core and the primary coil? Definitely the core has to be iron and the primary coil has to be copper. Diagram shows the magnetic field lines around the wire carrying current I. Which diagrams are correct? Okay, which diagrams are correct? Like, you will have to use the right hand rule grip. The right hand rule grip, in which if it was going into the paper, okay, or if it was going out of the paper. Okay, if it's going out of the paper, it would have been like one, going out of the paper, right hand rule grip. Okay, and going into the paper, it would have been like three. This is correct, and this is correct. So D. Okay. Question 36. A wire is placed between the poles of a magnet. Which statements are correct? Which statements are correct? An AC current in the wire causes a changing force on it. Okay. A downward DC current in the wire causes a constant force on it. An upward DC force on the wire causes a constant force on it. They all seem to be okay. And this is the case. Yes, they are all correct. And AC will keep on moving left and right. Okay. DC downward. Okay. For example, if we say DC current, which is downward, for example, the wire would move to the right. Okay. If it were upward, the wire would move to the left. So both are correct. The nuclide notation for the isotope lithium Li is 7 and 3. How many neutrons? 7 minus 3 is 4 neutrons. A radioactive material is emitting alpha particles. Radioactive material is emitting alpha particles. Which safety precaution, one of the most famous safety precautions while dealing with radioactive materials, is handling the source with tongs. Okay. What is the half-life of this material? How can I find the half-life of the material? Using this graph, what should I do? I should find the initial count rate and divide it by 2. The initial count rate in this case was 53. Okay, 53. I need to divide 53 by 2. 53 divided by 2 is 26.5. So using this graph, we can find 26.5, which would be around here. Okay, move all the way to the right and going downwards would be around 2 seconds. Okay, it would be around 2 seconds. A student measures the count rate near a radioactive source using the detector of ionizing radiation. The counter reads 75 counts per minute. When the source is taken away, the reading on the counter decreases to 5 counts per minute. What was the rate of emission from the radioactive source when the counter reading was corrected for background radiation? Okay, how can we correct it for the background radiation? This was the background radiation. And this was the count rate of the source plus the background radiation, which was 5. So 5 plus something would give you 75. This has to be 70. Okay, so 5 plus 70 is 75. And that's it.